I'm going to factor the first polynomial, x minus 3 times x plus 2. Factor the second one, 3 comes out, times x minus 3. And so the least common multiple has to have both of those parentheses to make the first expression go into it. The second one says I need a 3 out front also, so I can go into it evenly. The first expression goes into the least common multiple 3 times. The second expression goes over into this x plus 2 times. Okay, problem number 5. Do not say, ooh, my answer is x plus 4. Because if you say the answer is x plus 4, you can't answer the question of how many times does x plus 2 go into it. It doesn't go in 2 times, because if you multiply by 2, you get a 2x plus 4. So the answer is here that the least common multiple is the product of these two. Least common multiple right there. And so the first expression got multiplied by the x plus 4, and the second expression got multiplied by the x plus 2. In this case, the least common multiple was the product of the two given expressions. Okay, that is a key skill for the whole rest of the chapter. If we don't have those least common multiples down, we can kiss the rest of the chapter goodbye. We move on to adding and subtraction. Notice we already have a common denominator on problem number 6, so I rewrite this over common denominator, and then we just add across 5 plus 3 to get 8. There is no trick. In this second one, we already have a common denominator, thankfully. And if we add together x plus x, we get 2x. 3 plus 5, we get 8. And we would say we're done, but a careful eye will notice that we can factor a 2 out of the numerator. And upon doing so, there's a common factor of x plus 4 in both the numerator and the denominator, which cancels out, and you're left with a nice clean answer of 2. Number 8. You see the common denominator x minus 3. However, I need to warn you, this is where people get into trouble. When there's a binomial after your subtraction sign, you need to make sure to distribute that numerator, that negative, into the numerator. That numerator really becomes x plus 7 followed by minus x and minus 5. I can't tell you how often people make a mistake on that minus 5. Oops, sorry for not lifting that up, guys. Now, combining like terms, the x's cancel, and so 7 minus 5 makes 2 over x minus 3. Number 9. We don't have a common denominator yet. We can factor a 3 out of the first denominator, and then we say, ooh, x minus 5, 5 minus x. Those are not the same. I don't want to multiply them together. I'd rather turn this into an x minus 5 there. But you're not allowed to just do that. We learned with the -1 technique that technically x minus 5 and 5 minus x are off by a sign. So what we do upon doing that switch is we come around here and we change that minus sign into a plus sign. And that accounts for what we're doing here. Our common denominator will be 3 times x minus 5. The first fraction is going to have no change. It's going to stay 4. This second fraction, however, and going to the new denominator, will be multiplied by a 3. So we're going to have 4 plus 3x up in the numerator, and that's our answer. Okay, so here's another application of the -1 technique, or another way you can use it showing up within this problem. Number 10. Let's get that lined up there. We're going to have a common denominator of, well, 5 goes into 15. X but no x's. We're going to need an x. Y to the third versus y to the squared. We take the larger one. Now I could rewrite this as 2 separate fractions each over this 15xy cubed, but I choose instead to go as quick as I can to just a single fraction. So here we go. How has it changed? 5 times 3 makes the 15. The x is there, the y cubed is there. All we've done is multiplied by 3 down below. So we're going to multiply by a 3 up above and get 12 plus, which goes between the fractions. Now we look at the 15 and the 15, no change there. The x is new and one of the y's is new. So we're multiplying by xy going to that new fraction. Oh, I'm sorry, that's not visible there. And so 2x times xy gives us 2x squared y. Now you can leave your answer there if you have the foresight that it won't reduce, but technically you're supposed to at least mentally in your head ask whether you can factor out a 2. A 2 can divide out, leaving you with 6 plus x squared y over the 15xy cubed. But nothing is going to cancel. The 2 certainly won't cancel, and the whole parentheses won't cancel. So we really have a choice of which form we leave our answer in. There's two school of thoughts. One is leave it distributed. Another one is leave it factored. I like to say you're responsible for at least mentally factoring it and mentally noticing whether it will cancel or not, because if it does reduce, you're responsible for reducing it. So it's probably a good idea that maybe we do try.